when solving a system of inequalities, what we're going to be doing is really just depicting the solution graphically, because we're going to have all kinds of different solutions, lots of different points usually that satisfy all the inequalities. So what we do is we graph each inequality, and with each of those inequalities graphed, we have several different shaded regions. And what we're looking for is the overlapping region, okay? And that overlapping region that satisfies all the inequalities is called the feasible region, okay? When we're graphing it, we want to make sure that the feasible region is clearly depicted. And so we're always going to want to label the vertices, okay, which are like the corners of the region. So I'm just going to draw a quick picture so you can kind of see what it might look like. You might have a line that looks like this, and a line that looks like this, and a line that looks like that, okay? And maybe your shaded region, I'm going to do this in different colors so we can see it. So maybe we've got kind of above that line there, and maybe below that line there, and maybe below that line there. It's probably hard to see here, but what we have is the overlap is this triangle here. Okay, so this right here would be the feasible region, but these points right here, the corners of what's here, a triangle, we would want to make sure that those are labeled so that it's very clear what the feasible region is. With solutions of inequalities, an important concept is that of boundedness. And a region we'll call bounded if we can enclose it in a circle. Okay, so I'm going to draw two regions here. One is going to be bounded and one's going to be unbounded. So like our last little picture, okay, we have like a triangular region. Okay, and if this region here, notice we can find a circle that contains that region entirely. Okay, and so this would be an example of a bounded region. However, if we were to have a region maybe that resulted from two different lines, maybe these two lines, and was maybe the region that's shaded down below, okay, and it just goes forever and ever and ever, then there's no circle that we could draw to contain it because it just keeps going, right? It just keeps shading, and so there's no one circle that would contain everything. And so this is an example of something that is unbounded. And this is going to be an important concept when we're looking at applications of systems of inequalities. So we want to make sure that we can clearly identify whether a region is bounded or unbounded.